All right, everyone, we're going to work through just setting up lesson numbers 1, 2, 3, and 4. So all the word problems on here, and then your homework is going to be to finish solving these. Okay, and if you have questions on the setup after even watching this, make sure you come and visit an office hour. So number 1, a rectangular box has a height of 7 centimeters and a volume of 336 cubic centimeters. The length of the box is 3 times the width. They want us in part A to write an equation describing the situation, and part B to find the length and width of the box. So just so you have a visual, we can think of, I'm not sure if this will necessarily be drawn to scale, but they tell us it has a height of 7 centimeters. Okay, then they tell us that what the volume is, we're going to keep that in mind, and the length of the box is 3 times the width. So I can say that this is the width, let's call that x. If it helps, you can write down this is the width side. And then that makes this here the length, and they say that the length of the box is 3 times whatever the width is. So the width is x, so it's going to be 3x. So this is 3x. So the values I'm working with here, I have dimensions of 7, x, and 3x. Okay, now they tell me that the total volume of the entire thing comes to 336. So what I would suggest for part A is use your understanding of volume. Now, rectangular prism, I think we're familiar as length times width times height. So now you're literally just going to substitute everything in there. Okay, I'll just take that with you. So 336 equals 3x times x times the height of 7. Now your job is going to be to simplify this for part A. Okay, write an equation. So simplify that, that will be your equation. Now for part B, you're going to go ahead and find the length and width of the box. You're going to solve this equation, and once you find what x is, you can sub it back in to find the length and width. Okay, so I encourage you with each of these, even before we go on, try them on your own. I'm talking through it because obviously we're not in class, so I can't really let you kind of ponder it out and walk around and see where everyone is. So try them on your own and use these as some hints. All right, number 2, the height y in yards of a flop shot in golf, I'm not very familiar with that, but hopefully you are, can be modeled by that equation rather, y equals negative x squared plus 5x, where x is a horizontal distance in yards. How far away does the golf ball land? Okay, so what I'm going to do to help us get an understanding of this is I'm going to draw on a little coordinate plane. They tell us that the height is y, so this is y, and this represents my height. And that's in yards, okay? And then they go on to tell us x is the horizontal distance in yards. So this is my x value. This is the horizontal distance. And again, it's in yards. Okay? Now the ball, I understand that whenever we hit it, it's going to go up and come down. Okay, so here's our equation. They want us to go ahead in this problem find how far away does the golf ball land. So they want this value here. So we know that when we solve quadratics using either factoring, solving by square roots, or quadratic formula, we end up getting these answers here. They basically want to know that one. Okay, so your job is going to be to solve this using whatever method makes sense to you. Remember that any point where it crosses the x-axis has a y value of 0. So really, when you solve this, you're subbing 0 in for y, and that's should look very familiar to what we've done. And it's up to you. You can use quadratic formula. Square roots will not work here because you have a linear term, but you also could look to factoring if you want to do that. Whatever makes most sense, okay, in your mind. Okay, number 3. Your friend completes a high jump competition at a track meet. The function, doesn't say the rest, the function h equals negative 16t squared plus 18t models the height and feet of your friend after t seconds. So the first part, let's again kind of get a visual for what's happening here. So they tell us h is our height in feet. So that's the height in feet of our friend after t seconds. So this is our x value. That's why they have t in here and h right here. This is like my y, these are like my x's. Okay, so your friend competes in a high jump competition. So they're going to go, again, they're going to go up and they're going to come down. All right, after how many seconds is your friend at a height of 4 feet? So key here, height is 4 feet. So I just mentioned what variable represents height. Hopefully you're saying it in your head. It's either h or t. And yeah, it's going to be the h. So what you're going to do to start this one, instead of it being h equals negative 16t squared plus 18t, you're going to put 1 does 4 equal negative 16t squared plus 18t. Okay, so what I did is I took this equation, this function here, and substituted, instead of it being h, they say h is 4 feet, so we put 4 in place of h. Now if you want to solve this, we know that you can't solve a quadratic unless everything's on the same side. So that's what I would recommend you do. Either take 4 over to there, or you could take negative 16t squared, add that to both sides, and subtract 18t, whatever. Again, there's lots of ways. That's kind of the beauty of it. And sometimes the frustration, there are so many options, okay? But only one right answer. That'll help you out with A. Now part B, after how many seconds does your friend land on the ground? Again, that's this point right here. So that's whenever the h value is 0. So they want to know after how many seconds. Our ordered pair is t for seconds, h for height. After how many seconds is h 0? So you're going to solve the same thing, but this time you put 0 in place of the h value. And this one's actually going to be a little bit easier to solve. You can solve by factoring or quadratics. Again, solving by square roots won't work because you have this 18, this linear term here, so you can't do that. But either of the other options work. Factoring, pulling out a GCF if it exists, or going ahead and using quadratic formula. All right, last one. Use the given area of the rectangle to find the value of x, and then give the dimensions of the rectangle. So, all right, so area, again, like we saw above, is going to be length times width. They give us area. This is similar to that one that we started with. They give us length, and it's up to you which you prefer to call length. By our properties, commutative property, the order isn't essential. So I'm going to do 4x plus 3, and then I'll here do 4x minus 5. All right, now to solve this, just like we did actually in some of our practice ones, what we saw before in chapter 7, you have to FOIL this out first, okay? So then you're going to have 209 equals a quadratic. And we can't, like we saw up above, you can't solve a quadratic when you have some stuff on this side, some stuff on that side. So your next job is going to be to subtract 209 from both sides. Okay, these are just some hints. Then you'll have 0 equals your whole term, and from here you can factor. Okay, that'll give you what x is, and it asks you, the last step is find the dimensions of the rectangle, so you'll sub x back in for your length and width. Okay, I will also post a video on these worked out, but I really want you to try them because that's how you're going to get better at it. And please, please, please see me with questions during our office hours if any of this doesn't make sense. They're just, I got cut off there, but these are, please see me during office hours. These are just little short generic hints, but everyone has their own way of looking at it, so see me with any questions. All right, thanks again, guys. Bye-bye.